Energy is also energy. 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 SI unit. SI unit is joule, right? Also, or you can say kilogram meter square per kilogram meter square per second square, right? Also measured, also measured in calorie, right? One calorie, one calorie, one calorie is equal to amount of amount of work done work done to bring change in temperature of 1 gram water 1 gram water by 1 degree Celsius, right? This was earlier, earlier, right? Now, now 1 calorie 1 calorie is amount of work done amount of work done amount of work done to bring change in temperature temperature of 1 gram of water 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius, right? I hope you understand. Amount of energy first, amount of 1 calorie 1 calorie is 1 calorie is amount of work done to bring change in temperature of 1 gram of water by 1 degree Celsius. And now 1 calorie is amount of work done to bring change in temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So here temperature is specified. Here it is not specified. This is the difference, right? This much. नहीं you can write मतलब you can, now this is more appropriate. ठीक है. One more thing is there. One more thing is there that As I told you, power power is equal to work upon time, right? Work upon time. So what is work? That is F into S, and that time is T, right? And yesterday I told you this is displacement upon time is known as velocity. So we have a formula P is equal to F into V. I hope you understand this, right? And one more thing, volt is equal to potential difference V. V is equal to work done per unit charge. V is equal to W upon Q. This is potential difference. This is potential difference. This is one work done, and this is charge, right? So we can say work done. We can say work done. Work is equal to V into Q, right? So its unit is this is measured. It is potential difference is measured in volt, and charge is measured in coulomb, right? So we can say that 1 joule is equal to 1 volt coulomb. Fine. So 1 electron volt means 1 electron volt means charge on 1 electron, that is 1 into 1.6 into 10 to the power minus 19 coulomb into 1 volt, right? So we can write it 1.6 into 10 to the power minus 19 coulomb volt, right? And that is equal to 1 joule, right? So we can write 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Ready? So in best of my knowledge, this much was left, which I not told you during my session. When today I was teaching my students, I find these two, three things I have not discussed. So, right. So, one more thing that is not very important as such, but you can say that hmm, when an object is, this is the ground level, this is the ground, and there is an object like this, right? So this is having weight that is equal to m into g, right? And its height from the ground is h. So work done, work done, work done due to gravity, due to gravity is equal to W is equal to F into S. F is equal to weight into H. Weight is equal to mgh, right? So this is work done due to gravity, right? Can you tell me? So this is work done due to gravity. Work done, work done due to gravity, right? Now, can you tell me what is free fall? Free fall. What is free fall? It is written. Is it visible to you? Can you tell me what is free fall? हाँ. ये तुम देख के बोल मतलब you are looking reference to your book or you know that? देख लिया करो. Go through with your book. It is written in box. Where it is? Where it is? Very nice. So free fall is when when object is when object is falling when object is falling only under the gravitational 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 pull of earth and no external force acting on it acting on it, right? Then said to be said to be object falling under under free fall. Free fall. Fine. I hope you understand this. So this much is left, right? Okay. Should I up? Yeah, I'm good. I'm good. Now we come to energy, right? Energy is energy, right? Energy, kind of work done, kind of work done, right? So it is when due to position, due to position, due to position known as potential energy, potential energy, right? And potential energy. So F is, so we know that F is equal to F into S, right? F into S. So F into S. So if force is M into G and S is equal to H, then W is equal to mgh. It is known as potential energy, right? So we have gravitational potential energy, gravitational, gravitational potential energy, gravitational potential energy due to gravitational gravity of Earth, gravity of Earth, right? We have elastic potential energy. What happens? Hello, hello. Elastic potential energy, elastic potential energy due to due to due to elasticity, elasticity, right? And what else is written in your book? Gravitational potential energy, elastic potential energy, and one more, I hope. What is that? Huh? What happens? Okay, forget about that. That we will discuss. So this much. Now we have when 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 work done due to due to motion, motion known as movement, known as known as when what kind of work done. So work done when due to position known as potential energy, and when due to motion known as kinetic energy. Hello, kinetic energy, right? Okay. So we have a formula that is known as V square is equal to u square plus 2gh, right? When an object is falling, when an object is falling to ground, so at highest point, at highest point, at height h, so u is equal to velocity just before start falling, u is equal to 0, right? And suppose it is traveling a distance of h, so and acceleration a is equal to g, right? So we can say that v square v square is equal to 0, u is 0, it is 2gh, right? When you bring this on the other side, so half v square is equal to gh, right? So as you know that w is equal, as you wrote there, w is equal to mgh, right? Here substitute in place of gh, so w is equal to m into half v square, right? So we can write w is equal to half m v square. This is known as kinetic energy. This is known as kinetic energy. Kinetic energy, right? So should I rub this? Okay. Now we have we have work energy theorem. Okay. We have work energy theorem, that is work energy theorem, right? So work energy theorem, it means W is equal to Fs, right? W is equal to Fs, and if I take F is equal to m into A, and S is equal to S, as I told you, V square minus U square upon 2A is equal to S. Getting my point? From where I get? From the equation of motion, third equation of motion, V square is equal to U square plus 2AS. We arrange this in this format, so now we can write here V square minus U square upon 2A. Fine. When you multiply this, then this A and A is gone, right? Then you have this is equal to W. So W is equal to M bracket V square minus U square upon 2, right? So we can write it W is equal to half mv square minus half m2 square, right? So work is so work is equal to difference in difference in kinetic energies. Kinetic energies. Getting? This is this is work energy theorem we have. Done. 5 minutes. Okay, take 5 minutes. Move on. Now visible. Adhika, you are done. Okay. Should I rub? No. Okay. Now law of energy conservation. Huh? Law of law of law of energy conservation. Fine. First is first law is energy can neither be created nor nor destroyed. It changes from one form to another form, right? Like like solar energy, solar energy, solar energy is stored in chemicals form, chemical form, chemical energy, chemical energy, chemical energy in solar cells, and from these solar cells, it is converted into electrical energy. Electrical energy. right? And many more form of that, right? And the next one is sum of sum of potential energy plus kinetic energy is equal to constant, right? Is equal to mechanical energy. Mechanical energy, right? So it means mgh plus half mv square is equal to constant, right? This is law of energy conservation. Law of conservation of energy, we can say. Law of conservation of energy, right? This is. Should I? No, no, no. It can be said law of energy conservation, yeah, law of conservation of energy. Thing are same.